Alright guys, so we're going to be going through the entire review video here on this here. Now the first thing we're looking at is 1 through 6 here, determining whether x and y show direct variation, inverse variation, or neither. Now the easiest one to pick out of these three is neither, because direct and inverse variation deals specifically with multiplication or division. So if there's addition or subtraction, it is immediately neither. And we can look at these here, and looking at 1 through 6, well, number 3 has addition, so this is neither direct or inverse variation. Number 6 has addition, so this is neither also. Also, one thing we never really mentioned, but direct and inverse variation have to have x and y. It has to have both. It has to have both x and y, because if it doesn't, then it's neither. Because, I mean, we could have 6x equals 7. This is neither. It's not direct or inverse. It doesn't have both x and y. Have to have both. It's kind of something we've glossed over, but if it doesn't have both variables, it is neither. Now, out of all these here, direct variation comes in a few forms. Y equals a times x. X equals a times y. Or we can say a is equal to y over x, or a is equal to x over y. So if it comes in one of these forms here, it's direct variation. Inverse variation. Y is equal to a over x, or we can say x is equal to a over y, or a is equal to x times y. So if it shows up in one of these three forms, it is inverse. So we have these forms here. So direct. I don't know why I didn't just write this on this page here. Now, when we look at the first one here, 8y equals x, well, that matches up to one of these two here, so this is direct. X times y equals 1/5, well, x and y being multiplied together is this form here, so that is inverse. Number 4 is 6 over x equals y. Since we have x in the bottom of the fraction, like this one right here, and y by itself, this would also be inverse. So again, we're just matching it up. And I didn't state it earlier, but a in all of these is just a number. A is just standing for a number. Number 5 is just like number 2 in setup, so it is also inverse variation. So we have these here. Now we're not going to worry about 7 through 8 because or 7 through 9. They're not even going to show up on the test, so I'm not going to worry about going over them here. Because if we were to determine if it is direct, inverse variation, or neither, we're looking at our a is equal to x times y for inverse, so we would be multiplying them together. So number 7, we would take 4 times 16, which is 64. Then we do 5 times 11, which is 55. And if these two numbers that we get were the same, we would keep going through the rest, and it would tell us it's inverse. Well, since they're not, inverse is not going to work. Now direct, y over x. So 16 over 4 is 4. 11 over 5 doesn't reduce, so it's not direct either. Because if we got the same number each time, then it would be that one there. But these aren't going to show up. Now we're going to look at 10 through 13. Simplify each expression if possible. So we're going to simplify all the way down. Now number 10, the numerator is as simplified as it gets because it's a single term. One term, can't simplify further than that. Now the denominator, 3x squared minus 4x. Well, 3x squared and 4x do have a greatest common factor because that's what we should always be looking for first. And the greatest common factor is x. Doesn't always have to be a number, it can be a variable. 3x squared and 4x do share x. And we take an x from 3x squared, we're left with 3x. Take an x from 4x, we're left with 4. Giving us 2x squared over x times 3x minus 4. Now we do have an x in common on top and bottom, which will reduce out. So the one on bottom reduces, leaving us with 3x minus 4. The numerator still has 2, and our x squared is going to become x to the first, leaving us with 2x over 3x minus 4. And that's it. 11. Now the numerator, 32x squared minus 50. Again, greatest common factor. We need to be looking out for those. 32 and 50 do have a greatest common factor of 2. And if we take 2 out of 32x squared, we have 16x squared. And when we factor 2 out of 50, we're left with 25. Now our denominator, 4x squared minus 17x plus 15. There is no greatest common factor, but we can factor it. 2 sets of parentheses with 3 spaces. Since the third term is positive, our signs are the same and match the sign of the middle term, minus and minus. Factors of 4x squared. Well, our x squared is going to be x and x, because that's the only way we can multiply x and get x squared is x and x. Factors of 4. 1 and 4 or 2 and 2. Well, I'm going to start with 1 and 4. Factors of 15. 1 and 15, 3 and 5. Well, I'm going to do 5 and 3. And again, we can check and make sure that this works. 4x times negative 3 is negative 12x. Negative 5 times x is negative 5x, giving us negative 17x. Now that is the middle term we wanted, so these are the correct factors. So we can continue going from here because the numerator is still factorable. Our 4x minus 5 and x minus 3 in the denominator, the bottom of the fraction, are simplified as they get. Now the reason we know 16x squared minus 25 is factorable, one of the things is x squared just kind of does give us away. But 16x squared is a perfect square. That's 4x and 4x. 25 is 5 and 5. And since they're being subtracted, this is a difference of perfect squares. They multiply together to give us 16x squared minus 25. Now, part of the reason this is nice is because once we factor this, we do have a 4x minus 5 in common on top and bottom. And we can cancel it out because we have multiplication between our terms, not addition and subtraction. There's not an addition and subtraction sign between these spots here. So what we're left with on top is 4 times x plus 5 over x minus 3. And we will not have to list any of the restrictions on the test. We're just simplifying. And that goes for all of these here. The only time we'll need is if it asks for us to check our solutions, it would be good to list out our restrictions there so that we can check them. And we'll point that out later. Now, x cubed minus 27, this is not going to show up on the test. So I'm going to go on and give you what it factors out to be here. We're not going to have to worry about sum or difference of 2 cubes or factoring by grouping. So I'm going to give you this here. Now the numerator, x squared minus 7x plus 12. Since the third term is positive, our signs are the same and match the sign of the middle term. Minus and minus. Only factors of x squared are x and x. Now our factors of 12, 1 and 12. 2 and 6, 3 and 4. Now we need to pick which one we want. Now, if we want something to match on top and bottom, well, having an x minus 3 would be helpful. So 3 and 4 would be a possible choice for this here. And if we check this, x times negative 4 would be negative 4x. Negative 3 times x would be negative 3x, giving us negative 7x, which is indeed the middle term for the numerator. So these indeed are our factors. There we go. And since those are our factors, well, we do have an x minus 3 in common on top and bottom. That would cancel, telling us that our final answer is x minus 4 over x squared plus 3x plus 9. Now the denominator does not cancel, and that's partially due to the properties of our difference of two cubes. But that's it here. Let's look at number 13. We're going to need to factor the numerator and denominator, and I always start with whichever one I can find the factors of easier first. And x squared minus 4 is going to be that one there, because it's a difference of perfect squares. We'd have x and x, 4 would be 2 and 2, we have plus and minus. Now x squared minus 4x plus 12, since the 12 is negative, our signs are opposite. The third term's negative, the signs are opposite. Factors of x squared, only factors of x squared are x and x. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. Well, if we want to get something to match up, we'll probably use 2 and 6. So we'll plug those in there. And again, we can check this here, x times negative 2, negative 2x. 6 times x is plus 6x, giving us a positive 4x. So that's not the middle term we wanted. And whenever we get the correct number but wrong sign, well, flip the signs. Because when we flip the signs, x times 2 is now positive 2. Negative 6 times x is negative 6x, giving us the negative 4x that we wanted. And now that we have them factored, well, we have an x plus 2 in common on top and bottom, leaving us with x minus 6 over x minus 2. And that there would be our final answer. Perform the following operations. Now, there's not going to be any monomial multiplication, problems like 14 on the test. I'll go on and look at them. Because here, all we're going to do is multiply straight across. 4 is the only number on top. X is the only x on top. Y cubed times y would be y to the 4th. The denominator, 8 is our only number. X squared times x would be x to the 3rd. Y is by itself. So we get this here. Now we can simplify top and bottom. 4 over 8 is going to be 1 over 2. X over x to the 3rd. Whenever we divide like bases, we subtract the exponents. 1 and 3, so 3 minus 1 is 2. And since it's bigger on bottom, it stays on bottom. And last one, 4 and 1 with our y's. And 4 minus 1 is 3. And since it's bigger on top, stays on top, telling us that this reduces to y cubed over 2x squared. Now, problems like 14 won't show up on the test, but 15 will. And whenever we do problems like 15, the first thing we need to do is to factor with our multiplication. So our 2x and x minus 1 do not simplify, mainly because 2x is a single term. X minus 1 does not have anything in common, and since it's x to the 1st and not x squared, those are as simplified as they get. We can put parentheses around them at this point if we want to. We don't necessarily have to. Now we can look at x squared minus 4x. Now since there's only 2 terms and not 3, greatest common factor. Greatest common factor between x squared and 4x is, well, x. And if we take an x away from x squared, we're left with x. Minus x away from 4 is 4. So we have x times x minus 4. Now our x squared plus 3x minus 4, we have 3 terms. Since our third term is negative, our signs are opposite. Only factors of x squared, our first term, are x and x. Factors of 4, 1 and 4, 2 and 2. Well, we already have a 1 on bottom, and it's our x minus 1. So there's a good chance we're hoping for an x minus 1 to be a factor on top. Now we can check this here and make sure. X times negative 1 would be negative x. 4 times x would be plus 4x, giving us 3x. So that is the correct set of factors. Now at this point here, we can multiply these together. And for our numerator and denominator, we're really just smushing them all together because it's understood for multiplication. Our denominator, we'll move the 2x out front, and it's being multiplied by our x minus 1, giving us this here. Incidentally, we do have something in common on top and bottom that cancels our x minus 1 and x minus 1. And actually, we also have x and x, leaving us with x minus 4 times x plus 4 all over 2. That there is our final answer. 16, we do have a little bit more factoring to do. Because our x squared plus 3x minus 4 is going to factor. Our x squared plus 4x plus 4 will factor. Our x squared minus 4x plus 3 is going to factor with 2 sets of parentheses. Now our last spot, 2x squared plus 4x, we won't need 2 sets of parentheses. Partially because we don't have a constant term. But also, the main thing to factor with this is our greatest common factor of 2x. Because if we take 2x out of 2x squared, we have x. Plus, if we factor 2x out of 4, we have 2. This is how that one factors. Now, our x squared plus 3x minus 4, I'm going to factor it next. Since the 4 is negative, our signs are opposite. Only factors of x squared are x and x. Factors of 4, 1 and 4, or 2 and 2. We can do 4 and 1. Now we can check it, but these are the correct factors, and we actually just factored that a minute ago. Now that leaves us with our 2 denominators, x squared plus 4x plus 4. Since the third term is positive, our signs are the same and match the sign of the middle term, which is going to be plus and plus. Only factors of x squared are x and x. And our factors of 4 are 1 and 4 or 2 and 2. Here I'm going to use 2 and 2 because if we check this here, x times 2 is 2x. 2 times x is plus 2x, giving us a middle term of 4x, which is the middle term we wanted. So we have x plus 2 and x plus 2. That brings us to the last one. X squared minus 4x plus 3. Since the third term is positive, our signs are the same and match the sign of the middle term at minus and minus. And well, the only factors of x squared, x and x, only factors of 3 are 1 and 3. And we can check this to make sure. X times negative 3, negative 3x. Negative 1 times x is negative x, giving us a middle term of negative 4x, which is the middle term we wanted. So these are our factors. Now at this point here, we can multiply this all together. Now the numerator, I'm going to move the 2x up front. Now how we arrange the rest of our factors doesn't really matter. We just need to make sure that they're listed. The denominator does not have any monomials expression like our 2x to move up front, so we can leave it as this. here. At this point, we need to cross out what's in common on top and bottom. Well, x minus 1, x minus 1, x plus 2, x plus 2. And that's it. So it leaves us with 2x times x plus 4 in the numerator and x plus 2 times x minus 3 in the denominator. And that's it. All right. Now we're going to look at 17. Now we do technically still have two fractions. It's just that the denominator of our other one here is 1. Since the numerator is x squared plus 2x minus 8, we will have two sets of parentheses. We don't have a greatest common factor between the two, so we can't factor that out. Same thing's true with our other numerator, x squared minus x minus 12. There is no greatest common factor here, so we'll do our two sets of parentheses. We do know it's two sets of parentheses because we have three terms. And the last one, x squared minus 16. There's not a greatest common factor. And even though there aren't three terms, we do have an x squared and a constant term. X squared is a perfect square. X and x. 16 is a perfect square. 4 and 4. And since they're being subtracted, it is a difference of perfect squares. Now it doesn't matter which one we look at next. I'm going to look at x squared minus x minus 12. Their term's negative, so our signs are opposite. Factors of x squared are x and x. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. I'm going to go with 3 and 4 because there's a good chance we'll have a set of like terms on top and bottom. So I'm just going to plug it in, set it up this way, and check. X times negative 4 is negative 4x. 3 times x is positive 3x, giving us a middle term of negative x. So that is the set of factors that we wanted. So we get this set up here. Now we still need to factor the x squared plus 2x minus 8. Since the third term is positive, our signs are opposite. Only factors of x squared are x and x. Now our factors of 8 are 1 and 8, 2 and 4. So I'm going to pick 4 and 2. Now at this point, the x minus 4 and x minus 4 are gone. So if something is going to simplify, we need it to simplify with our x plus 4. That's part of the reason I chose this here. Now we can check this. X times negative 2 is negative 2x. 4 times x is plus 4x, giving us a positive 2x that we wanted. Now at this point we can multiply them together. Well, x minus 4s are gone. All we have left in top is x plus 3 times x plus 4 times x minus 2 over x plus 4. Now as we see here, we do have an x plus 4 in common on top and bottom, and they would cancel out, leaving us with x plus 3 times x minus 2. Now technically it is over 1, but division of 1 we don't have to list. Now if the numerator was left as 1, we do have to list it. Okay. Now in 18, also like 14 is not going to show up on the test, but I'll go on and show it anyways because one of the properties with division still holds true. That we keep the first rational expression the same. We change it from division to multiplication and flip the second. And then we multiply these together. Now the first thing we're going to do is 32 times 8. We can grab our handy calculator, say 32 times 8, 256. Then we're going to do x to the third times x to the fourth is x to the seventh times y. Now in the denominator, we have y to the 8th times y to the 7th is y to the 15th. Because when we multiply like bases, we add the exponents. Now there's only one thing that simplifies. It's y over y to the 15th. 15 minus 1 is 14, and since it's bigger on bottom, stays on bottom. 256 x to the 7th. So there's not a whole lot that simplifies there, but we're not going to have these monomial terms. We're going to have something like 19. Now before we start factoring, First thing we want to do is keep change flip. So the first one's still going to be x squared minus 3x minus 40 over x squared plus 8x minus 20. We flip the second one, so now it's x squared plus 12x plus 20 on top, and x squared plus 13x plus 40 on bottom. Now at this point here, we do need to factor. Well, I'm just going to start with x squared minus 3x minus 40. Since the third term's negative, our signs are opposite. Factors of x squared are x and x. 40 is 1 and 40, 2 and 20, 4 and 10, 5 and 8. Well, the correct set of factors are 5 and 8. And we can check it and make sure, and we would indeed get negative 3. Now I'm just going to move straight down, x squared plus 8x minus 20. Since our third term is negative, our signs are opposite. Factors of x squared are x and x. Now our factors of 20 are 1 and 20, 2 and 10, 4 and 5. Well, at this point, I would be leaning towards 4 and 5, but it won't give us a middle term of 8, but 10 and 2 will. Now, one thing I will point out that none of these here expressions have a greatest common factor, so we won't factor anything out there. Now, our x squared plus 12x plus 20. Since the third term is positive, our signs are the same and match the sign of the middle term. Factors of x squared are x and x. Now, our factors of 20 are still 1 and 20, 2 and 10, 4 and 5. But if we're going to have something that matches, 2 and 10 is going to be our key. And it does work out, x plus 2 times x plus 10 is the correct answer. Last one, x squared plus 13x plus 40. Since the third term is positive, signs are the same and match the sign of the middle term, plus and plus. Factors of x squared are x and x. And the factors of 40 that we want, well, 8 and 5. Because we want something to match, and that would give us what we need. Now at this point here, we can multiply these all together. Now the denominator, x plus 10 times x minus 2 times x plus 8 times x plus 5. Multiply them all together. Now since they're being multiplied, we can cancel out what's in common on top and bottom. X plus 5, x plus 5. X plus 10, x plus 10. And what that leaves us with is x minus 8 times x plus 2 over x plus 8 times x minus 2. Now the order in which we write them doesn't matter. We just have to have the terms on top and bottom. And that's it. And for the most part, addition and subtraction, not addition and subtraction, multiplication and division aren't too different. Division, we just have to keep change flip. And that's it. Addition, subtraction. If the denominators are the same, no matter what they are, if they are the exact same expression, add or subtract the numerators. 20, the denominators are already the same. So we can take our two numerators, 4x squared, and subtract from it 1. We can subtract them from each other, which is just going to give me 4x squared minus 1. Now we do need to make sure the numerator is not factorable once we subtract or add. And here it is, 4x squared minus 1 is a difference of perfect squares. Because 4x squared is 2x, 2x. 1 is 1 and 1. Telling us that we have 2x plus 1, 2x minus 1 over 2x minus 1. We do have something in common on top and bottom. They cancel, telling us that it is 2x plus 1. And that's it. Let's look at 21. Here, the denominators are already all the same, and since they're all the same, we can go on and add the numerators. So we'll be adding our 9x squared, our 6x minus 1, and 6x plus 5 over 3x plus 2. Combine like terms. We have 9x squared. 6x plus 6x is plus 12x. Negative 1 plus 5 is plus 4. And we get this here, 9x squared plus 12x plus 4. Now we need to make sure that if the numerator factors, we factor it. Now there is no greatest common factor between 9, 12, and 4, so we can't factor it out. Since the third term is positive, our signs are the same and match the sign of the middle term. Plus and plus. Factors of 9x squared, well, we have x and x. Well, our factors of 9 are 1 and 9 or 3 and 3. Now to pick which one we want, well, if we want something to simplify, well, it'd be nice if we had a 3x. So we'll try 3 and 3. Factors of 4, 1 and 4, 3 and 2. Well, also be nice to have a positive 2, so we'll do 2 and 2. If we check the middle term, 3x times 2, 6x. 2 times 3x is plus 6x, giving us the middle term that we wanted. So that is the correct factors, and we do have something in common on top and bottom. So a 3x plus 2, one of them will cancel out on top and bottom, leaving us with 3x plus 2. And that's it. Now, if one of the numerators does factor out completely, the top of one of the fractions factors out completely, it reduces to 1, and we do have to leave it as 1. It does not simplify out completely and go away. It would still just be 1. (22). So if the denominators are not the same, we need to get them to be the same. And before we do that, we need to factor. Now, x plus 7 is not factorable. There's no greatest common factor, no sets of parentheses. But our x squared plus 5x minus 14, there is no greatest common factor between these three terms, but it is factorable, 2 sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite. Factors of x squared are x and x. And our factors of 14 are 1 and 14 or 2 and 7. 7 and 2. And it works out that these are the factors for this here. And it's kind of nice because x plus 7 is shared. Now the numerator, x squared minus 5 is not factorable, and it doesn't even matter. Even if it is, we don't factor it. Because our goal at this point is to get the denominators to be the same. Now, both of these have an x plus 7, and they only have it once. So there's nothing we have to do with that there. It's just that the one on the left has an x minus 2. The one on the right does not have that. So we just need to multiply the one on the right by x minus 2 over x minus 2. Because if we do that, the one on the left's denominator is x plus 7 times x minus 2. The one on the right, now x plus 7 times x minus 2. The denominators are now the same, and since they're the same, we're going to be able to add or subtract. Now the numerator on the left is still x squared minus 5. The numerator on our right, we have x plus 3 times x minus 2. And I feel it's easier to be able to start subtracting if we have this numerator multiplied out. So we're going to do x times x, x squared. X times negative 2 is negative 2x. 3 times x is plus 3x. And 3 times negative 2 is negative 6. Now, before we can officially start subtracting, we do need to combine like terms. and that's mainly on the right side. X squared doesn't have any like terms, but our negative 2x plus 3x is going to be plus 6x minus 6. Turn the page. Now we can subtract. So we have x squared minus 5 minus x squared plus x minus 6 over. Now when we subtract, well, we don't, what we're going to do is drop the parentheses. These first set of parentheses, the sign won't change because there's nothing in front of it. Now our minus, our subtraction, has to be applied to the second set of parentheses, making it negative x squared, negative x and positive 6. And lastly, go back down, we can combine like terms. X squared minus x squared is 0. Negative x is the only x term. Negative 5 plus 6 is plus 1 over x plus 7 times x minus 2. There's nothing in common on top and bottom, so that is our final answer. All right, 23. Three fractions. Now the numerators aren't going to change. Even if they were factorable, we're not going to factor because there's no point in factoring them. It's not going to get us anywhere. It's not going to do anything. So we're going to leave them as they are. Not going to do a thing to them. And we're not going to have one with 3 expressions being added together. We're mainly going to have 2, but it's good to look at it anyways, because we're going to need to multiply all of them by something to get the denominators to be the same. Well, to get the least common denominator, well, what's going to make them be the same? We need x minus 4 and 3x minus 1. The one on the far left, well, we need an x and 3x minus 1. I'm looking at that. And we get that there. The middle term is going to need x minus 4 and 3x minus 1. And the last one's going to need x and x minus 4. I get these to be the same, and as I'm looking at this, if you really want to see this done, I'm going to provide it. You can ask me, I can show you how to do this later. It's not going to help here, it's just going to probably be more confusing. This is not going to show up on the test, we're not going to focus on it. So we're going to move on. Least common multiple. We want to find the least common multiple for each of these here. We want to see what is the first expression that's going to make them be the same. And to do that, we need to factor them out completely. Now 26, 2x squared is as factored as it gets. Now 4x plus 12 will factor a little bit further. And the only way it factors is by a greatest common factor, which is 4. And we take a 4 out of 4x, we're left with x. Factor 4 out of 12, we get 3. So we have 2x squared and 4 times x plus 3. Well, for our least common multiple, one part of it that we need is x plus 3, because we need this expression. Now we need to get the 4 and 2x squared to be the same. Well, we'll need x squared And the first number that 2 and 4 makes them be the same is, well, 4. And that's it for that there. Now we can look at 27. Now our x squared plus 3x minus 40 is factorable, so we'll have 2 sets of parentheses with 3 spaces. Since the 40 is negative, our signs are opposite. Third term's negative, the signs are opposite. Factors of x squared are x and x. And factors of 40, 1 and 40, 2 and 20, 4 and 10, 5 and 8. We're actually going to have 8 and 5 for this here. And if we check this here, x times 5 is negative 5x. 8 times x is plus 8x, giving us a positive 3x. So those are the factors that we wanted. Least common multiple between these here. Well, the one on the left has an x plus 8, the one on the right does not, so we need an x plus 8. The one on the left has an x minus 5, the one on the right doesn't, so we'll need at least one x minus 5. And lastly, we need an x minus 8. So we end up just taking all the terms from both. 28. Again, before we get started, we need to factor them. Well, x plus 7. Two expressions. The degree is 1 because the variable of exponent attached to the variable x is 1. That's as simplified as it gets. X squared minus 2x minus 63. This factors 2 sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite. Factors of x squared are x and x. Factors of 63 are 1 and 63, 3 and 21. 4 does not work, 5 doesn't, but we have 7 and 9. And if we check this here, that would give us negative 9x plus 7x is negative 2x, the middle term that we wanted. Since that's factor, we can find the least common multiple. So let's check our factors. The one on the left has 1x plus 7. The one on the right has 1. Even though they both have it, since it's only listed once, we need it once. We also need x minus 9. So here the least common multiple was x plus 7 times x minus 9. Last one, 29, 4x squared minus 16. First thing we need to factor is 4x squared. Now there is a greatest common factor of 4 between 4 and 16, and we can factor it out. And we factor it out, we get 4 times x squared minus 4. Now our x squared minus 4 is a nice set of factors, or a nice polynomial 2 factor, because it's a difference of perfect squares, which is x plus 2 and x minus 2. Now we're going to move on to 6x squared minus 24x plus 24. Well, here we have a greatest common factor of 6. And if we factor that 6 out, we're left with x squared minus 4x plus 4. At this point here, we can factor this here. Since the third term is positive, the signs are the same and match the sign of the middle term, negative and negative. Factors of 4 are 2 and 2. So we get this here. Now at this point here, find least common multiple. Well, 4 and 6, the least common multiple, the first number we can turn both of those into is 12. Now let's look at our other terms. The one on the left has an x plus 2. The one on the right does not, so we need it once, because it was only listed once on the left, so we need it once. Now the one on the left also has 1x minus 2. The one on the right has 2. So we need it not once, but twice. So this here is the least common multiple. And yes, we could rewrite it as 12 times x plus 2 times x minus 2 squared. Either one of these would work. You just need one of them. Now that does lead us into the last set of problems, which is solving. And on the test, if it does say check your solutions, I believe it does say just check your solutions. It actually does not say that. It just says be careful of extraneous solutions. Because if it says or tells you to be careful of extraneous solutions, most likely an extraneous solution is going to show up. Otherwise, it's not a necessary step, but we can go on and look at it anyways, because 31 are restrictions. It's just going to make, or is going to be from whatever is going to make the denominator be 0. With our 2 times x, well, that's just telling us x cannot be 0. With our x plus 6, x cannot be negative 6. So for 31, if we get a value of x as 0 or negative 6, it won't work. Now the first part of this problem is to multiply the entire equation by x plus 6 and 2x. Because here the 2x and 2x will cancel. The x plus 6 will cancel, leaving us with 4 times x plus 6 is equal to 5 times 2x. Now at this point here, we could have multiplied the 5 and 2x, giving us 10x. The other side, we're going to distribute the 4. 4 times x is 4x. 4 times 6 is 24. Now because we only have x to the first power, we don't have an x squared, x to any other power, we just need to get x by itself. We can subtract 4x from both sides. Telling us 24 is equal to 6x. At this point, we can divide by 6, telling us x is equal to 4. And that's it. It's not one of our restrictions, so x equals 4 is the solution for this one here. And that's it. Well, instead of rewriting this whole thing out, we'll move on to the next one. Our restrictions are going to come from x minus 3 being equal to 0 and x squared minus 27 being equal to 0. This one here we would add 3, telling us x cannot be 3. For other one, we would add 27 to both sides, telling us x squared equals 27, or x is equal to plus or minus the square root of 27. Well, square root of 27 does simplify. It is 3 squared roots of 3. So if we get 3 or positive negative 3 squares of 3, neither one of those will work. Now it may be very tempting to want to factor x squared minus 27, but it actually doesn't factor. It's not a difference of perfect squares, because x squared is a perfect square, but 27, there is not a number multiplied by itself that gives us 27. So nothing to factor. But what we can do first is we can for sure multiply both sides by x minus 3. Because on the left, the x minus 3 and x minus 3 will cancel. But our right's denominator did not. So we're going to also have to multiply by x squared minus 27 so that the right side's denominators will cancel, leaving us with negative 1, or negative times x squared minus 27 is equal to x minus 4 times x minus 3. At this point here, we can distribute. We're going to distribute the negative, giving us negative x squared plus 27. Here we're going to distribute the x, giving us x squared minus 3x. Distribute the negative 4. Negative 4x plus 12. At this point here, we can combine like terms. Negative 3x, negative 4x combined to give us negative 7x. Now at this point here, because we do have an x squared term, we need to get this equal to 0, so we can add x squared to both sides. Telling us that 27 is equal to 2x squared minus 7x plus 12. At this point here, we can subtract 27 from both sides, which will give us 0 is equal to 2x squared minus 7x minus 15. Two sets of parentheses with 3 spaces. Since our third term is negative, our signs are opposite. Factors of 2x squared are 2x and x. Well, x and x, only factors of 2 are 1 and 2. So I went on and just plugged them in. Factors of 15, 1 and 15, 3 and 5. 3 and 5. And we can check this here. 2x times negative 5 is negative 10x. 3 times x is plus 3x, and lo and behold, we do get the negative 7x that we wanted. Now, one of the nice properties in Algebra 2 that we have is our zero product property. Whenever we have 2 or more things multiplied together to equal 0, one of them must be 0. Now, for our x minus 5, we can solve from here, adding 5 to both sides, telling us x is equal to 5. For our 2x plus 3, we would start off by subtracting 3, then dividing by 2, telling us x is negative 3/2. So those there are our 2 solutions. All right, let's move on to 33. Now again, 33 is not going to have any restrictions. We're not even going to list them. So we're going to go on to our first step, is to multiply by our 2 terms. Our 2x plus 5 and 11x plus 8. On the right, the 2x plus 5 and 2x plus 5 would cancel. On the left, 2x plus 5 and 2x plus 5 cancel. On the right, 11x plus 8, 11x plus 8 cancel. And what that leaves us with is 1 times 11x plus 8, which is just 11x plus 8. On the other side, we have x times 2x plus 5. Now we will need to simplify our x times 2x plus 5, giving us 2x squared, plus 5x. We're just distributing it. Now since we have an x squared term, we need to get this equal to 0. We're going to subtract 11x from both sides, telling us 8 is equal to 2x squared minus 6x. Still not equal to 0, so we're going to subtract 8 from both sides, telling us 0 is equal to 2x squared minus 6x minus 8. Now at this point here, we can factor or graph it, either way, but there is a greatest common factor of 2. If it's a number, we can divide it out. We cannot do this with variables, because if we factor that out, we divide that 2 out. We get 0 is equal to x squared minus 3x minus 4. Now we didn't do this on the last one, but we can try graphing this. X squared minus 3x minus 4 graph. We do see that it crosses the x-axis in 2 nice places. So second graph, one of them is negative 1 and the other is 4, because when we graph it, we're trying to see what values of x will make the y value be 0. X is equal to negative 1 and x is equal to 4. Because if we factor this, we'd have x minus 4, x plus 1 as the factors. Whenever we have 2 or more things multiplied together to equal 0, one of them must be 0. And with our x minus 4, we would add 4, telling us x is 4. With our x plus 1, we would minus 1, giving us our 2 answers here. So factoring also works. 34. Now, unlike all the ones we've had so far, this one does have something that factors our x squared minus 1. Now, the nice thing is that it is a difference of perfect squares, which is going to be x plus 1 and x minus 1. And now that we have that factored, we're going to go on and start solving. So we're going to multiply everything by x plus 1 and and x minus 1. Now we can go through and make sure everything canceled. So an x plus 1 and x plus 1 cancels on the far left. In the middle, x plus 1, x plus 1, x minus 1, x minus 1. And since our 3 didn't have a denominator, nothing simplifies. So what that leaves us with is 4x plus 1 times x minus 1 is equal to 12, everything canceled, plus 3 times x plus 1 times x minus 1. Now at this point here, we can just start distributing. 4x times x is 4x squared. 4x times negative 1 is negative 4x. 1 times x is plus x. 1 times negative 1 is negative 1. Now we could distribute through here, but we'll get x squared minus 1. Because where did we get the x squared, or the x plus 1 and x minus 1 from? Well, they came from the factors of x squared minus 1. So if that's where they came from, they should multiply back together to get that there. Now we still have some more simplifying to do. Negative 4x plus x is negative 3x. Giving us 4x squared minus 3x minus 1. Here we can distribute the 3. Giving us plus 3x squared minus 3. Now before we start moving everything over, we do have one last set of like terms to simplify. 12 minus 3 is going to give us 3x squared plus 9. Now since we do have x squared terms, we need to get this equal to 0. 4x squared minus 3x squared is x squared. Minus 3x minus 1 is equal to 9. At this point we can subtract 9 from both sides, giving us x squared minus 3x minus 10 is equal to 0. Now at any point when we get the equation equal to 0 and there is no greatest common factor, a number in common with all three terms, we can graph it and get our answer. Or we can factor. Third term's positive, so the signs are the opposite. Whenever the third term's negative, the signs are opposite. Factors of x squared are x and x. Our factors of 10 are 1 and 10, or 2 and 5. The ones we'll want are 2 and 5. For x plus 2, we would subtract 2. Knowing this x cannot be, or not cannot be, x is negative 2. For the other one, we would add 5, telling us x is 5. So those are our two set of factors. Because here the restrictions would be plus or minus 1. Let's look at 35. Here, well, we can go on and start looking back at the restrictions because I believe they're going to start coming into play. They should. 3x is the only thing we have. So it can't be 0. So x cannot be 0. This is our only restriction. And it's these 3x's that are going to have the restriction. Since the middle term is just 6, it does not have a restriction because there's no variable we can plug into it. So one of the things we are going to have to multiply everything by is x. Now it's very tempting to just want to multiply by 3 and 6. It would give us the right number, but 3 and 6. Well, the first number that will make both 3 and 6 be the same as well, 6. So we're actually going to multiply everything by 6x. Because if we do this here, and I'm going to go on and write it out so that we see this, we have 2 times 6x over 3x plus 1 times 6x is just 6x over 6 is equal to 4 times 6x over 3x. Let's see how this simplifies. Well, on the far left, the x and x will cancel. In the middle, 6 and 6 will cancel. And on the far right, x and x. I'm just starting out with ones that we can see cancel easily. Now the next part is this here, 3 over 6. We still have the 2. And 3 divided by 6 is 2 plus x equals 4 times, well again, 6 over 3 is 2. And this is kind of nice because everything else simplified. And we can simplify this here. 2 times 2 is 4 plus x is equal to 8. minus 4 from both sides, telling us x is 4. And we get the answer here. Now we could have done this, and this would have been fine, 3x times 6, 3x times 6, 3x times 6, 3x, 3x cancels, leaving us with 2 times 6 is 12. Middle, 6 and 6 will cancel, giving us 3x. Lastly, 3x and 3x cancel, 4 times 6 is 24. Minus 12 from both sides, telling us 3x is equal to 12. So here, we do get to the same answer, but had an extra common factor of 3, which since it's just number, it works out well. But we do need to be careful with expressions, because if we have an expression extra, it will make things a little bit difficult or harder. 36. Our two restrictions are x minus 3, because we do have it twice, and x. Well, x by itself just tells us here in the middle that x can't be 0. With our x minus 3, we would add 3 to both sides, telling us x cannot be positive 3. So if we have positive 3 or 0, it would be one of our restrictions. We'd have to remove it. Okay. So when we start our first step, we need to multiply everything by x and x minus 3. And on the first part, x minus 3 and x minus 3 cancel, leaving us with 2 times x or 2x plus. In the middle, x and x cancel, leaves us with 1 times x minus 3. And lastly, x minus 3 and x minus 3 cancel, leaving us with x times x minus 1. So we get this here. Now at this point we can do some simplifying. So we'd have 2x plus, well here since the sign in front of it's a plus, we don't have to add the parentheses. We could have left them out originally because it's just going to stay x minus 3 is equal to, here we have to distribute the x. X times x is x squared, x times negative 1 is negative x. Too far down. Now we can combine like terms here. 2x plus x is 2x, be 3x minus 3 is equal to x squared minus x. Now at this point here, moving things from left and right, there's not a whole lot of difference, so I'm just going to move everything towards the x squared. So we're going to subtract 3x from both sides. Telling us negative 3 is equal to x squared minus 4x. Add 3 to both sides. Telling us 0 is equal to x squared minus 4x plus 3. Now just like the previous one, we can try factoring this. X squared minus 4x plus 3. So we plug it in and graph. You see it crosses the x-axis in 2 spots. We're trying to find out what values of x make the y value 0, which is positive 1 and positive 3. So here x is equal to 1, x is equal to 3. And that's it. Well, almost. Let's check restrictions. X cannot be 3. It's out, so our only value is 1. So if there is a restriction, we do have to remove it. And there's only 2 problems on the test that will have restrictions. 37, 38, 39. Last 3 problems, and then we're done with this review sheet. So at this point, for this one here, I'm going to write underneath part of 38, but that's also because I can erase easily to find our 2 restrictions. That would make x minus 5 be 0 and x minus 3 be 0. So for x minus 5, we would add 5. Telling us x cannot be positive 5. For x minus 3, we would add 3. Telling us x cannot be positive 3. Now the next thing we need to do is multiply through by our terms. So we would multiply everything by x minus 3 because our far right, the x minus 3 and x minus 3 would cancel. But it didn't cancel everything out, so we also need an x minus 5. And on the far right, the x minus 5 would cancel. In the middle, the x minus 5 would cancel. All of our denominators are simplified out. And what we're left with is x plus 3 times x minus 5 plus x times x minus 3 is equal to x plus 5 times x minus 3. Now we need to do some simplifying, so let's take this one expression at a time. X times x is x squared. X times negative 5 is negative 5x. 3 times x is plus 3x, and 3 times negative 5 is negative 15. Plus, since it's just this here, we're going to distribute through. We don't really need the parentheses after this because the sign in front of this is positive. So x times x is x squared. X times negative 3 is negative 3x. Here we're going to distribute x times x is x squared. X times negative 3 is negative 3x. 5 times x is plus 5x. And 5 times negative 3 is negative 15. Now at this point we can combine like terms. Well, x squared plus x squared is 2x squared. Negative 5x plus 3x is negative 2x. Minus 3x, well, we're back to negative 5x. And then negative 15 is equal to x squared. Negative 3x plus 5x is plus 2x minus 15. Now we need to get this thing equal to 0. I'm going to move towards the bigger x squared term. X squared minus x squared is 0. 2x squared minus x squared is x squared. Minus 5x minus 15 is equal to x minus 15. And no matter what we move x, I'm going to subtract 2x. So I have x squared minus 7x minus 15 equals negative 15. At this point here, we can add 15 to both sides, which actually works out kind of nicely. Negative 15 plus 15 is the 0 we wanted to get. Well, turns out it's actually 0 on both sides. Not the whole expression, it's just our constant term, leaving us with x squared minus 7x. Now at this point we can graph this, x squared minus 7x, and get our answer. But there is a greatest common factor of x. Now it's going to be very tempting to want to divide it out. We cannot divide it out. We can factor it out. We can factor the x out, giving us x times x minus 7. And since we have two things multiplied together to equal 0, one of them must be 0. Well, so either x is equal to 0 or x minus 7 is equal to 0. Well, x is equal to 0 is solved. Now we just have to solve the x minus 7, telling us x is equal to 0 or 7. Our restrictions were 3 and 5. Those are not one of our restrictions, so both of those solutions work. Last two. All right. Now we do have to factor this here. The x squared plus x minus 6 is factorable, so it needs to be factored before we can solve. So we need to factor x squared plus x minus 6. No greatest common factor, so we'll have two sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite. The only factors of x squared are x and x. Factors of 6, 1 and 6, 2 and 3. And it will work out that it's x plus 3, x minus 2. If we want to check this here, x times negative 2 is negative 2x. 3 times x is positive 3x, giving us a positive 1x. So we have this factored. Now we can look at restrictions. Well, the only two expressions that we have in the denominator that would make the denominator be 0 is our x plus 3 and x minus 2. For x plus 3, we would subtract 3, telling us x cannot be negative 3. The other one we can add 2, telling us x cannot be negative 2. So these here are our two restrictions. At this point here, we can multiply everything by the x plus 3, x minus 2. And can go from there, because we're wanting these to reduce and help us solve. And here, x plus 3 cancels. X minus 2, x minus 2. Nothing cancels with our 2 in the middle, but our x minus 2 and x minus 2 cancel. And what that leaves us with, well, on the far left we have 5. In the middle we have 2 times x plus 3 times x minus 2 plus x minus 3 times x plus 3. Now at this point we multiply out. Now we do have to leave the parentheses around this here because of the 2 in front. Because if there's a 2 or a minus when we're doing this distributing, this multiplying through, we do need to leave the parentheses there until we multiply or distribute it through. Now here we'd have x squared minus 2x plus 3x minus 6 plus, here we're going to do the distributing also, x squared plus 3x. Distribute our negative 3. Negative 3x minus 9. Now when we combine like terms, we have x squared plus x minus 6 plus. Here we don't really need the parentheses because there's not a number or minus sign in front of it. We'd have x squared, well the 3x and negative 3x becomes 0, leaving us with minus 9. Next thing we can do is distribute our 2, giving us 2x squared plus 2x minus 12. This here. Now, before we move the 5, we do need to finish combining like terms. 2x squared and x squared give us 3x squared. Plus 2x, because there is no middle term other than the 2x. Negative 12 minus 9 is negative 21. Now, since we have the x squared term, we do need to get this equal to 0. So we can add 5 to both sides. Telling us 0 is equal to 3x squared plus 2x minus 16. Now we can try graphing this if we want. 3x squared plus 2x minus 12. 3x squared plus 2x minus 16. Almost had it. Graph. We have this here. It does cross at one nice point, and that one nice point is 2. So we didn't get the other. And if we do get one nice number and not 2, we'll have to factor it. 2 sets of parentheses with 3 spaces. There is no greatest common factor, so we can't factor anything out. Since the third term is negative, our signs are opposite. Factors of 3x squared, well, x squared would be x and x, 3 and 1. Factors of 16, 1 and 16, 2 and 8. I don't know why I'm writing 3. It wouldn't be 3, it'd be 4 and 4. Now, since 2 was a factor, I'm going to pick 8 and 2 and try it. And if this doesn't work, we can switch it and try it again. 3x times negative 2 is negative 6x. 8 times x is plus 8x, giving us a positive 2x. So, that is correct. And at this point here, we have 2 things multiplied together equals 0, so one of these expressions has to be 0. Now for our x minus 2, we would add 2 to both sides. Minus x is equal to 2. For 3x plus 8, we would minus 8. Minus 3x is equal to negative 8. Divide by 3. Minus x is equal to negative 8/3. So these here are our 2 solutions. Now we can go check our restrictions. Well, x cannot be 2. It's gone, telling us negative 8/3 is the only solution that we have. That brings us to the last problem on the review sheet. Okay. Yay. Excitedness. Excitedness. X, and x. Doesn't matter if the numerator's simplified or factored at all because there's no point in factoring them. But we do have to factor the denominators, and there are 3 different spots that factor. I'm going to start with x squared minus 1 because it's a difference of perfect squares. So we have x plus 1 and x minus 1. Our middle expression, x squared plus 3x plus 2. Since the third term is positive, our signs are the same and match the sign of the middle term. Plus and plus. Factors of x squared, well, the only factors are x and x. And only factors of 2 are 1 and 2. And lastly, x squared plus x minus 2, when we factor it, because the third term is negative, our signs are opposite. Only factors of x squared are x, and our factors of 2 work out to be plus 2 and minus 1. Restrictions. Well, x minus 1 means 0. X plus 1 means 0, and x plus 2 means 0. Can we find the restrictions? Well, one of them is that x cannot be negative 2. For the middle one, x cannot be negative 1. And for our last one, x cannot be 1. So we can't have 1, negative 1, or 2. If any one of those 3 solutions shows up, we have to throw it out. Now to start solving, well, the first thing I can do is multiply everything by x minus 1, which is nice because one on the far right, one on the far left, it would cancel out. Now with the one on the far left, we would also need an x plus 2. Multiply it by the middle one, x plus 2 cancels. Far right, x plus 2 does not. But it doesn't simplify everything, because our middle term needs an x plus 1. One on the far right does also need an x plus 1. And since we multiplied it through, we have to multiply it by everything. And what that leaves us with is x times x plus 1 is equal to x times x minus 1 minus x times x plus 2. And incidentally enough, or oddly enough, this actually works out kind of nicely. Because here we can distribute the x. X times x is x squared, x times 1 is x. The middle one, x times x is x squared, x times negative 1 is negative x. And here we're going to distribute the negative x. Negative x times x is negative x squared. Negative x times 2 is negative 2x. Now at this point we can combine like terms. X squared minus x squared, well that is 0, that's gone. Negative x minus 2x is negative 3x. Well, since we have an x squared term, we do need to get this equal to 0, so we can add 3x to both sides. Telling us that we have x squared plus 4x is equal to 0. So at this point, we could graph it. We didn't graph it last time. X squared plus 4x. Graph. We see it crosses the x-axis at 2 places. One of them is at 0 and the other is at negative 4. Because again, when we graph, we're looking for what values of x make the y value be 0. X is equal to 0, x is equal to 4. Now if we factored it, we would pull out a greatest common factor of x, which would be x times x plus 4. And whenever we have 2 or more things multiplied together to equal 0, one of these 2 expressions must be 0. Either x is 0 or x plus 4. And when we solve x plus 4, we get that x is equal to negative 4. Restrictions, positive 1, negative 1, and negative 2 aren't listed here. So those are our answers, and that is everything on the review sheet that will be on the test.